Hello, welcome to the Unit 4 test review so that you can retake it. This one says solve the systems of equations. And for this system, I'm going to use substitution. And the reason why is because I already see a letter by itself. I already know what y equals. Y equals negative x plus 2. So where I see y in my other equation, I'm going to plug in a negative x plus 2. So I'm going to rewrite that first equation, 5x minus 7, and instead of putting y, I'm going to substitute this in for y. So negative x plus 2 equals 58. All right, now I have an equation to solve, so I'm going to draw my line down my equal sign and get going. All right, we got to take care of our parentheses first. So we're going to take this negative 7 and we're going to distribute it. So negative 7 times negative x is a positive 7x. Negative 7 times a positive 2 is a negative 14. And then I'm just going to bring the 5x straight down and the 58 straight down. Now I'm going to box off my letters. I have a 5x and a 7x. They're on the same side of the equal sign, so I can go ahead and combine them. I do not need to do opposites here because I'm not trying to move it to the other side. They're on the same side, so I just add them together. 7 plus 5 is 12 x's. Bring down my minus 14 and bring down my 58. Okay, I'm still trying to get that x by itself, so I need to get rid of a negative 14. Now this is when I am going to do opposites because I'm trying to get rid of it. So I have to do it to both sides of the equal sign. Those will cancel. Wait, did I do that right? That's a 4. Goodness gracious. I should just start this video over, but I'm not going to. So I'm adding 8 plus 4 is a 2. Carry the 1, 72. Woo, y'all. Okay. So anyways, now that I have this, I've still got to get x by itself. Right now it's 12 times x. The opposite of multiplying is dividing. So I'm going to divide 12 from each side. And 72 divided by 12 is 6. So we've done all this work and we've solved this equation, but we are not done yet. A system of equation, the answer to a system of equation is where the two lines meet, where they intersect. And anytime we're looking, I'm just going to sketch 2 lines. Anytime we're looking for a point where they meet, it has to be an ordered pair. So we're looking for an x value and a y value. So I know my x value is 6, but I'm not done until I have the full ordered pair. So now I have to go back and figure out y. Okay, so now I know that x equals 6, which means I'm going to go to my second equation, and where I see the letter x, I'm going to plug in a 6. So I'm going to write y equals negative and then put a parentheses for x. And in that parentheses, I'm going to substitute in what x equals, which is 6. And then negative 6 plus 2 is a negative 4. Now I know my x value and my y value, so I am done. That is my solution to the system of equations. All right, what is the unit rate of snowfall per hour? So for unit rate, remember we're trying to find out what happens for 1 unit. And in this case, we want to know what happens for 1 hour. So if we look down here at our graph, we have from 0 to 5 hours. We don't want to know that it snows 10 inches in 5 hours. We want to know what happens each hour. So I'm just going to look over here at 1 hour, and I'm going to follow it up to see where it is on the y-axis. And it might be helpful for you to go ahead and number these. 1, 2, 3, 4, 5. So in 1 hour, it snows 2 inches. So we would write this as 2 inches per hour. That would be our unit rate. Which function has a greater unit rate? All right, so when we deal with unit rate, we're kind of just trying to figure out the slope. That's another fancy word for that. So if we compare our two slopes, because slope is the rate of change. So unit rate and slope kind of mean the same thing. So since we're looking for the unit rate, we need to find the rate of change on each of these. When it's in this form, y equals mx plus b, that's a linear equation where m is always the slope. So the number attached to x, or the coefficient with x, is going to be our slope. So in this case, our slope is going to be 3. That's our rate of change. And then over here, if we want to figure out the rate of change, we need to see what's happening with our y values. So x's are increasing by 1 each time, and y's are increasing by 5 each time. And if we found our rate of change, or our slope, rise over run, you could think of it like that, as 5 over 1, or you could just look at the y value and say, okay, it's adding 5 each time, so that has to be our rate. So if we have 3 here and 5 here, then we can tell that the greater unit rate comes from the table. Is this a positive or negative slope? All right, we have a couple different ways we can find slope. Remember, we just mentioned that slope is the rate of change. It is the steepness of a line. So if we want to figure out the slope, we can either plot the points and look at the graph and find rise over run, or we can use the slope formula, which says y2 minus y1 over x2 minus x1. Doesn't matter which one you use, and in fact, I'm going to show you both pretty quickly. So when I look at a graph, or when I look at a t-table, I like to pick numbers that are pretty and easy. So I'm going to deal with these two sets of numbers because they're both positive. It just makes my life a little bit easier if I don't have to deal with negative numbers. So if I wanted to graph those two ordered pairs, I would go to 1, 2 and put a point there, and then I would go to 2, 5 and put a point there. This would be my line. Ooh, that's kind of a bad line. But if you wanted to find slope using rise over run, you could count that we rise up 1, 2, 3 spaces, and we run 1 space. And we know it's positive because that line is going uphill. So you could find the slope using rise over run, or you could find the slope using the slope formula. So if I'm going to use the slope formula, I need to label these. We know that this is our x value, so I'm going to go ahead and let this one be the first x value, and this one's going to be the second x value. I'm going to let this one be the first y value, and this one's the second y value. And then I plug them into my formula. y2 is 5, minus y1 is 2, the x2 is 2, and the x1 is 1. So 2 minus 1. And I simplify, and again, I get 3 over 1. I did all that to find the slope, but what I really needed to know was whether it was positive or negative. Well, remember, if a line's going uphill, it's positive. And if you solve for the slope and it is a positive number, then the slope is positive. You can also just look at the rate of change and see if you're getting bigger or smaller. And we're going from -7 to +5, so we are getting bigger. There's lots of different ways that you can tell that this slope is positive. And we're going to actually come back to this problem in just a minute. All right, we want to write an equation of a quadratic function. So for a linear function, I'm going to write linear next to this because this is not our answer. For a linear function, the form that we've been looking at most often is y equals mx plus b. That's a linear function. If we want to change that to a quadratic function, what we're looking for is we're looking for the x to have an exponent of 2. So it can look a bunch of different ways, but as long as our x has an exponent of 2, we know it's a quadratic function. It can have other numbers in here. It could have, like, let's just make one up. We can make any up that we want. So y equals, let's say, 2x squared minus 3. That could be a quadratic function. It could look a different way. It could be like y equals x minus 2 squared minus 3. You still have the exponent of 2 that goes with the x, because if you distribute that exponent, it will go with both. So anytime you have an x with an exponent of 2, it's going to be a quadratic function. An example that is not a quadratic function, so linear, that was not a quadratic function. And if you see something that has an exponent of 3, that is not a quadratic function. We're not looking for any exponent. We're looking specifically for the exponent of 2. Okay, write a function rule to represent the data in this table. So remember I said we were going to go back and use all this information that we already found. This is the same table. So I'm going to use all of this information for number 7. When I write a function rule, I need to write the whole equation. So y equals mx plus b, where m is my slope and b is my y-intercept. Okay, so we already talked about how you can find slope for this. You can either find the rate of change, you can graph it and see the rise over run, or you can use the slope formula. So we did all of that back here. We looked at the rate of change, we looked at the graph, and we looked at the slope formula. So I already know in this case my slope is 3. Oops, wrong question. So I'm going to go ahead and write down that my m, or my slope, equals 3. So what I still have to do is I still have to find the y-intercept. Now, if you think about a graph, if we come over here and think about a graph, the y-intercept is where it touches the y-axis. No matter where the point is on the y-axis, all of those points have an x value of 0 because they don't go positive in the x direction or negative in the x direction. They are right on 0 for an x value. So if we want to find the y-intercept from a table, we look for an x value of 0, and that will tell you the y-intercept. So in this case, the y-intercept is -1. And then we can just plug that into our formula, y equals 3x minus 1, and that would be our function rule, or linear equation, however you want to say that. All right, the price of an ice cream is $3.95 plus 90 cents for each topping T on the ice cream. Which function rule shows the cost of an ice cream per number of toppings T? All right, so it asks us to do a function rule, which we know is y equals mx plus b. We want to know the cost of an ice cream. So I think they call that letter C. Let's see. Oh, price of ice cream is P. Okay, sure, we'll make it P. The price of ice cream is P, and toppings, we're going to give the letter T. So let's go ahead and figure this out. It says the price of ice cream is $3.95 plus 90 cents for each topping. So if we just wrote it out exactly in the order it says in the sentence, we would write the price equals $3.95 plus 90 cents per topping. So I'm going to do 90 times T. But most likely, if this is, and that's fine, that is a correct equation. But most likely, if it's a multiple choice test, it's going to want it in this form, which just means that the slope, or the number with x, comes first, and then the y-intercept comes second. So in this case, we could rewrite it, our letter is t, and the coefficient with that is 0.90. So we could rewrite this as 0.90 times t plus $3.95. This is probably the way it will be written. But the red way and the purple way are both correct. It just depends on what your answers look like. Okay, so for this one, I must have cut off the question. Sorry about that. But we're trying to figure out which equation matches this graph. Y'all, honestly, I would probably go to Desmos and I would type each of these in. Desmos is a free calculator that all of you can use. So I would type each of these in and see which one matches. I'll go ahead and give you some heads up for how to do it without a calculator. The last number here is going to be kind of like, you can think of it like the y-intercept. If it's plus 3, it's moving it up the y-axis 3, and if it's -3, it's moving it down the y-axis 3. So we're not doing that. We know it either has to be A or D. So we're actually moving it along the x-axis, 3 spaces, but it's the opposite of what you would think. It's actually a +3, even though we're moving in the negative direction. We'll talk more about that later, but I got to get to this last question before my time runs out. So we want to solve the system of equations. You guys can do this a couple different ways. Since it's multiple choice, I'm going to go ahead and show you a strategy called plug and chug, where you just substitute each of these in and see which one works. And I am going to pause the video and show some work and then explain it in just a second. All right, so what I did here is I took my x value of -1 and I plugged it in for x, and then I plugged in my y value for y, and I tried to see if it equaled what it was supposed to equal. And in the first problem, I got -5, which doesn't equal -1, so I knew that couldn't be the answer. And then I did the same thing for each of these. I plugged in a +1 for x and a +1 for y, and I tried to see if it equal, oh, it was supposed to equal +1. Sorry, that's a misprint there. Supposed to be +1. Either way, I got 5, and 5 does not equal +1, so B could not be the answer. Wait a minute, that's still -1. I'm talking crazy. Anyways, y'all, if you plug in each of these, you will see the only one that works is D. Good luck on your retake. Let me know if you have questions.